Good evening, everyone. This is the Die Hard group, staying to the last session of the day, even during happy hour. Wow. I feel like we should be at Google back during one of our TGIF meetings. We can all crack open a drink and just sit here and chat. So, anyhow, thank you very much for joining our session this evening. My name is Joe Cava, and I'm the Vice President of Data Centers. So that means that I lead the teams that design, build, and operate our data centers globally. And I really appreciate your interest in this topic today. So I'm going to share with you a little bit about what makes Google data centers so unique. So let's first start by considering, what do you need from your data center? All right, sorry, we're going to go to plan B. See, as a good data center guy, I've always got a backup plan. Anyhow, so whether you're currently in your own enterprise data center or you're in a multi-tenant co-location facility, what you need is access to high-performance computing, always available around the world, when you need it, where you need it. And that's exactly what you get I know that, as I mentioned, you need access to high-performance computing available around the world in highly available and secure data centers. Well, with Google Cloud, that's exactly what you get. You get it where, when, and how you need it. We've been leaders in developing ultra-high-performance, reliable compute systems since the earliest days at Google, and using the most innovative designs. And no matter how good our teams and our systems perform, we always feel that we can do better. So we have a relentless focus on innovation. And our high-performance computing is the result of optimizing throughout the entire stack. Nearly all of our infrastructure is custom designed and purpose-built for our own computing needs. From our own dedicated high-voltage substations, to our customized electrical distribution systems, to our cooling systems designed and built purposely just for our data centers, all working in conjunction and optimized to provide the highest performance and lowest total cost of ownership computing anywhere. You know, when I first joined Google 9 years ago, I was amazed at the extraordinary lengths that the company went to build our own systems. And of course, as I learned more, it became obvious why we do that. But at the time, I thought to myself, I'm like, what makes us so unique? Why don't we just buy servers like everyone else? Well, we go through all the extraordinary effort because, frankly, what we needed at our scale didn't exist when we started. In order to achieve the performance, efficiency, and price targets, we had to build our own servers. We had to develop and create the hardware and the software and the culture of reliability to make Google successful. Our servers don't include any unnecessary components, such as video cards, chipsets, or peripheral connectors, which can introduce vulnerabilities. Our production servers run a custom-designed and stripped-down version of Linux that's been hardened. And our servers and their OS are designed for the sole purpose of powering Google services only. Our server resources are provisioned dynamically. They're allocated and allow for us to be flexible in growth, and they can be re-provisioned quickly and efficiently, adding capacity where it's needed, when it's needed, to quickly respond to customer demand. And recently, we've also contributed our learning and our experience with our custom 48-volt rack systems. We've contributed that design to the Open Compute program. So now Open Compute program racks also work in Google data centers. And you know, since I've been at Google, we've fundamentally redesigned our cooling systems about every 12 to 18 months. And along the way, we've pioneered and developed advancements in water-based cooling systems, such as seawater cooling, recycled gray water cooling, stormwater capture and reuse, rainwater harvesting, industrial canal water use, and thermal energy storage. And we've also designed data centers that don't require any water for the cooling at all. Instead, they're cooled with 100% outside fresh air. The point is that there is no one-size-fits-all model here. All of our data center designs are custom for that specific region, that specific location, to get the best efficiency. We also invest a lot in robotic innovation in our data centers. Each of our data centers has fully automated disk erase environments. This allows for faster, higher throughput, more efficient, and better inventory management. Now, of course, along with performance and innovation, you need data centers in locations that work for you. And at Google, our numerous locations and fiber network differentiates us from the rest. Our IP network consists of our own fiber, public fiber, and undersea cables. And this allows us to deliver highly available and low latency services across the globe. But it also means that we can respond faster to demand, efficiently scaling our capacity for when you need it and where you need it. It's even been noted by several industry publications that this is clearly a standout for Google. And, of course, as you can imagine, with the explosive growth in public cloud computing, we've had some pretty aggressive expansion going on ourselves. And, of course, our global network brings our data centers close together and closer to you. We're available currently in 6 regions and 18 zones with over 100 points of presence. And our data network is comprised of hundreds of thousands of miles of fiber optic cable. To ensure every customer has a cloud region near them, Google Cloud will add several more regions in 2017, including the ones that were announced just this morning by Urs. So we now have new regions available in the Netherlands, Canada, and California. We need to operate our own data centers around the world to keep our own products running 24/7. Our data centers are part of a very robust infrastructure that supports Google's scale. And Google's global network, including our 4 owned undersea cables, which is far more than any other cloud provider has. And our edge points of presence, where we connect Google's network to the rest of the internet, via peering, of course. And having those multiple points of presence across the globe provides strong redundancy, so your data is securely mirrored across storage devices in multiple locations. By choosing Google Cloud, you can build on the same future-proof infrastructure that Google builds on. It's the same infrastructure that Google uses to return billions of search results in milliseconds, the same infrastructure that Google uses to serve over 1 billion hours of YouTube a day, the same infrastructure that Google serves over 1 billion Gmail users every day. And at the core of our program really is our commitment to availability. I've been doing this a very long time, and I've evaluated dozens, if not hundreds, of public and private data centers all over the world. And I can tell you that they're not all created equally. So when we say truly 7 by 24, we really mean it. Our designs are fault tolerant, and this protects you against potential failures. And our critical infrastructure is concurrently maintainable. This means that whenever something breaks or maintenance is needed, we don't have to take down services to do that. There's no such thing as scheduled outages on Google Cloud. This is invisible to you, and it enables us to do all of this live. So we design our data centers with an eye towards the future. So we build in hooks that allow us to take advantage and upgrade our systems and network with the latest platforms developments. But we also staff our data centers 24/7 with our own team of Googlers who have been intimately designed from design, or they've been intimately involved from the design through construction and commissioning and through operations. They're the best and the brightest engineers and operations professionals available anywhere, but they all come from very diverse backgrounds, and they have one common trait, all of them. They're systems-level thinkers. Many of them have come from mission-critical environments like the Navy nuclear submarine program, where mistakes can be catastrophic. They understand mission-critical operations. Further, we've built site teams at all of our data centers that are comprised of the engineers responsible for the design and construction of the data center, working side by side with the operations teams. Their experience and qualifications is unmatched. The majority of our staff hold advanced degrees in professional licensing. They've been published in technical papers and books, and they hold patents relevant to the industry. And together, these integrated teams are responsible for the capacity commissioning and providing 7x24 operations. This really gives us an unparalleled level of end-to-end ownership of our infrastructure. Having Googlers operate our own data centers is really key. You see, the norm in the industry is for the design-build contractor to hand over a set of documents, drawings, and manuals and the keys to the front door and wish the data center operator good luck. And all too often, the operations teams aren't even employed by the owner of that data center. They're actually employed by the lowest cost outsourced bidder. So their level of ownership is maybe not quite what we believe it should be. And if there's one certainty in mission-critical operations, it's that faults and errors are going to happen in the middle of the night, typically on a weekend, when no one else is around to help, and all your suppliers are closed. But that's not the case at Google, because it's us. We're there 24/7. All of our teams are working around the clock to provide the most available compute infrastructure. But equally as important as the operational excellence is transparency. And really, we want to have the continual learning that when an issue does arise, that we can expose that issue and send it around the world to all of our teams so that everyone can learn from it. We studied the root cause of errors and issues in the industry based on published data. And on the infrastructure side, the industry norm is that human error accounts for the overwhelming majority of all incidents. However, because of our designs, and frankly because of our very highly qualified people, only a small fraction of our issues are related to human errors. And of those, none of them has ever caused any downtime at our data centers. So, in addition to high performance, innovation, and availability, you want your data center to be environmentally sustainable as well as secure. So first, let me talk about sustainability a little bit. Google data centers are the most efficient and environmentally friendly in the world. For as long as I've been building and operating data centers, I've been an advocate for efficiency and sustainability. Running our business in an environmentally responsible way is important to us, and it's something that we also know it's important to you. It takes a tremendous amount of power to run at our scale. As a matter of fact, last year, the total amount of energy consumed in Google worldwide for all of our operations was just almost equivalent to the total amount of energy consumed by the city of San Francisco in the same year. But we want to be really good stewards to the environment, even though we are consuming a lot of power. And we want to use renewable energy as much as possible. So this year, we're very, very excited to announce that in 2017, Google is going to reach 100% renewable energy for all of our global operations, data centers and offices combined. This means that for the calendar year in 2017, Google is directly purchasing enough wind and solar electricity to account for every unit of electricity we consume globally. This is a huge milestone for us, and it's frankly the culmination of 7 years of effort from all of my colleagues across the company. So how did we get here? We started this journey back in 2010 when we did our first wind deal with a wind farm in Iowa. Back then, we were amongst the first corporations to go out and buy renewable energy directly. We then started expanding, doing more deals globally, and moving more into solar along the way also. We now have 20 deals that are equivalent to 2.6 gigawatts of renewable energy. And this has generated emissions reductions that are equivalent to taking 1.2 million cars off the road. And in doing so, this makes us the largest corporate buyer of renewable energy in the world, and by a wide margin. And thanks in part to the work of renewable energy tariffs and our power purchase agreements and the related efforts by our peers in the industry, the number of corporate renewable energy deals is soaring. We've been committed to sustainability since the earliest days of our data center program, and we've been carbon neutral for more than 10 years now. And in addition, we've had a number of accolades along the way, awards and high marks. Most recently, Google achieved a final grade of A in Greenpeace's 2017 Click and Clean report, which benchmarks the energy performance of the IT sector. And only 3 companies out of the 15 that they evaluated achieved that A grade. So it's something we're very proud of. We're very excited by the growth in renewable energy, and we're dedicated to increasing the ability of customers to take control of their energy supply. But there is more work to be done. We continue to look for new ways to help utility business models become more customer-centric so that cost-effective renewable energy is available to anyone who wants it. And finally, security is of the utmost importance in our data centers. Our infrastructure is protected by more than 800 top experts in information, application, and network security. And Google's focus on security and data protection is amongst our primary design criteria. Our physical security team, or our physical security systems, feature a layered security model, including safeguards like custom-designed electronic access cards, alarms, vehicle access barriers, perimeter fencing, metal detectors, biometric authentication, and our data center floors are protected by laser beam intrusion detection. Our data centers are monitored 24/7 by high-resolution interior and exterior cameras that can detect and track intruders. Access logs, activity records, and camera footage are available in case any incident does occur. And our data centers are also routinely patrolled by very experienced security guards who have undergone rigorous background checks and training. And the closer you get to the data center floor, the more rigorous the security systems get also. As a matter of fact, to gain access to the data center floor, it's only available through a secure corridor that requires badge access, biometric authentication, and passing through anti-tailgate devices. And only approved employees that have a specific role to be on the data center floor ever set foot there. That means that less than 1% of our employee population ever set foot in one of our own data centers. We employ a very strict end-to-end chain of physical custody for storage, tracking everything from cradle to grave, from the first time a hard disk goes into a machine until it's verified, cleaned, and erased. We know everything about that media. We know who touches it, when it was touched, what it was touched for, and why, what's its next expected action. Our information security and physical security go hand in hand. As you know, data is most vulnerable when it's in transit, and for this reason, securing data in transit is our highest priority at Google. Data traveling between customers' devices and our data centers is encrypted using HTTPS TLS, so transport layer security. And in fact, Google was the first major cloud provider to enable TLS encryption. And this homogeneous environment is maintained by proprietary software that continually monitors the system's binaries for any binary modifications. For our teams to be successful, they must have advanced real-time visibility into the status and functionality of our infrastructure. As you know, to say that Google is obsessed with data might be a little bit of an understatement. So our teams build systems that allow us to monitor everything. We've built world-class monitoring and control systems for all functional areas, from the servers and storage and network to the electrical distribution, the mechanical cooling systems, and the security systems. We're monitoring all aspects of performance and operations from chip to chiller. And as I've mentioned, energy efficiency is at the heart of our sustainability program. We believe that the best energy saved is the energy not consumed in the first place. That's why we pioneered hyper-efficient computing systems and data centers. And that's why our data centers consume, on average, only half of the energy of a typical enterprise data center. What makes us really stand out in this regard is how we've applied machine learning to drive energy efficiency even further. If you've been in the keynote speeches over the last couple of days, you've heard how much emphasis Google has been placing on our machine learning programs. Well, you can imagine our data centers are very large and complex, where the electrical and mechanical and control systems are all working together to deliver optimal performance. But because of the sheer number of interactions and possible settings for all of these systems, it's impossible for us mere mortals to visualize what the best way to set up the data center controls are for those specific operating conditions, and to do it in real time. However, really, it's fairly trivial for the computers to crunch through all of these possible scenarios and find the optimal settings. So over the past couple of years, we've developed an algorithm, and we've trained it with billions of data points from all of our data centers all over the world. We now use machine learning models to help visualize this data so the operations teams can set up the data center electrical and cooling plants for the most optimal, efficient performance on any given day. It's also used considering up to 19 independent variables like the weather outside, the temperature, the humidity, the wind direction, the wind speed. All of these things go into how efficient a data center runs, but without a machine learning model, it's almost impossible for the operations teams to try and adjust that in real time. So in partnership with our colleagues at DeepMind, our data center team built models to recognize and learn from these patterns in the large amounts of operational data that we collect every day anyhow. We're storing it and not really using it that well. So now this is, over some trial and error and perfecting the model is now over 99.6% accurate in predicting our PUE. And PUE is power usage effectiveness. It's a measure of data center efficiency. And it has helped us to identify up to 40% savings in the data center cooling overhead. This equates to an overall 15% reduction in our PUE, which may not seem like a lot, but if you think about the hundreds of megawatts of data center capacity that we have online every year, that is equated to several tens of millions of dollars in energy savings per year. But you might wonder, why? Why do I care? Why do I care if your data centers are efficient? Well, one of the reasons why you care is because Our operating costs are directly related to the efficiency of our data centers. Our pricing on Google Cloud is directly related to our operating costs. So the more efficient we are internally, the more of that savings we can pass through to you, and we can offer the most high performance, lowest cost public cloud available. In leveraging our strength in this machine learning, we've succeeded in increasing the overall efficiency of our data center fleet. This makes Google the data center you need, the one that you really can't afford to be without. High performance computing available around the world, secure, reliable, where you need it, when you need it, and how you need it.